Hello, this is FlippedHarber for Precalculus, and in this video we'll cover section 3.7, complex zeros, and the fundamental theorem of algebra. Our objectives for this lesson are to utilize the conjugate pairs theorem to find the complex zeros of a polynomial, find a polynomial with specified zeros, and find the complex zeros of a polynomial. Our topics include zeros, complex numbers, and complex zeros. The outline for this video will talk about complex polynomials, the fundamental theorem of algebra, the conjugate pairs theorem along with the corollary with it, and finding a polynomial whose zeros are given, and finding the complex zeros of a function. Now, a complex polynomial is pretty much exactly what it sounds like. It's a polynomial, just like we're used to, but the coefficients are complex numbers. Now, we could think of absolutely every single polynomial that we've worked with as a complex polynomial because a real number can be thought of as a complex number. It's just that the imaginary part is zero. So everything that we've learned up to this point still works perfectly. As a matter of fact, we're just really adding to what we already know. Now, again, we want that constant at the end. We want that a sub 0. If you don't have the a sub 0, your first step is to factor an x out front. Then what's left is a polynomial with that constant at the end. Alright, now the fundamental theorem of algebra says that every complex polynomial function f of x of degree n greater than 1, that means that there's at least an x term, but probably an x squared, an x cubed, and so on and so forth. It has at least one complex zero. Now that may not sound too shocking, too exciting, too big. Why is this the fundamental theorem of algebra? Well, we're not guaranteed a zero with real polynomials. You know, if I asked you what are the zeros of a lot of quadratics, they don't have zeros because that quadratic doesn't go through the x-axis. But if we look at it as a complex polynomial, we are guaranteed to have some zeros. They just might be complex numbers. Alright, so there's a theorem that goes along with this. It says that every complex polynomial of degree greater than or equal to 1 can be factored into n linear factors. That means that absolutely every polynomial can be factored. It's just not always going to be pretty. Sometimes it's real factors, x minus 5. Sometimes it's complex factors, x minus 5 plus 2i. Okay, so every single one can be factored though. It's just that sometimes those factors are complex numbers. Alright, so here's a big one, the conjugate pairs theorem. If we have a complex polynomial, and remember, every polynomial that we've worked with up to now can be thought of as a complex polynomial. So let f of x be a complex polynomial whose coefficients are real numbers. That's what we've been doing. If r is a 0 and r is a complex number, a plus bi, then its complex conjugate also has to be a 0. So that means that if we have a polynomial that we're working with and we find out that a complex number is a 0, automatically its conjugate is also a 0. Now, this actually explains in Descartes' rule of signs why we take away even multiples. So Descartes' rule of signs, you see that there are 3 real zeros. We have to say there are 3 or 1. The reason we're taking away 2 is maybe 2 of those zeros are complex conjugate zeros, which come in pairs. Alright, so there's a corollary that goes along with this. If complex zeros come in pairs, then if we have an odd power, complex zeros can only come in pairs, we have to have at least one real zero. Now that's kind of like a warm fuzzy blanket. At least we can find that real zero using our P over Q type stuff. And then what's left over, those pairs of complex zeros. So if it's got an odd degree, you can be sure that it has at least one real zero. Okay, so let's talk about finding a polynomial whose zeros are given. What they're going to do is they're going to tell you a degree for the polynomial. So in this case, we want a degree 4. That means we want x to the 4th power. They tell us that 1 and 2 are zeros. That's great. Those are real numbers. Those are easy to work with. They also tell us that 2 plus I is a 0. Well, since complex zeros happen in pairs, we need to know that 2 minus I is also a 0. So we add a complex 0 to this list of zeros. And for each of those zeros, we're going to make a factor. So since 1 is the 0, x minus 1 is the factor. And then we're going to multiply everything together. Now, this is going to get a little bit ugly. I'm not going to lie to you. But I'm going to also show you how to do it easily. So we got a degree 4. We know that 1 and 2 are zeros. We know that 2 plus I is a 0. And we know to add 2 minus I is a 0 because complex zeros come in pairs. So for each of those zeros, we make a factor. 1 is the 0, x minus 1 is the factor. 2 is the 0, x minus 2 is the factor. Now you might be wondering, why didn't I put the 2 plus 1 in parentheses? Because x minus that whole thing. Well, basically not because I shouldn't do it, but because it really doesn't matter. If I put 2 plus 1 in parentheses, when I distribute that negative, I get minus 2 minus I. So not putting my complex zeros in parentheses is not a big deal. Okay? So moving right along, what I'm going to do is I'm going to go ahead and multiply the first two binomials together. We know how to do that. There shouldn't be any big surprise. X minus 1 times x minus 2 is x squared minus 3x plus 2. Now, dealing with these complex factors, there's a lot of stuff to multiply together. I'm going to show you the gory details here, but then I'm going to talk to you about how to do it quickly. Okay? Now, if we take each of the numbers or letters in the first set of parentheses and multiply them into the second set of parentheses. Now I'm talking about the complex factors. X times x gives me x squared minus 2x minus xi. Then I move on to the minus 2, multiply that through, then the plus I, multiply that through. This is what I get. It's a lot of crap. I know. I realize that. I typed it in. But realize also that a lot of stuff cancels. Well, specifically, those x minus i's cancel. And hey, the two i's cancel. So what's left over is my x squared. I've got a couple minus 2x's. Those will combine. I've got my plus 4. And then at the end, I've got minus I squared. You should know what that is equal to. So we're going to get rid of what we can. We're going to combine what we can. And we can even combine a step further. That minus I squared is actually a plus 1. So we get x squared minus 4x plus 5. Okay, how do we do that quickly? Well, it's equal to the x squared. So you always start with that. So when you're multiplying your complex factors, it always starts with x squared. The minus 4x comes from my real portions of my complex number multiplying the x. So it is always minus, and then the real portion multiplied times 2 times x. Now that plus 5 is what I get from multiplying the complex conjugates together. 2 plus I times 2 minus I always equals 5. So if you can get this pattern down, you can skip all that factoring work that we saw on the previous screen. Alright, that's going to take some practice though. That's what the homework's for. So let's move on. I then distribute things through, basically multiply these two trinomials through, and I combine like terms, and here is my degree 4 polynomial that has 1 as a 0, 2 as a 0, 2 plus I as a 0, and the 2 minus I that I knew I needed to add as a 0. It's a good thing. Alright, now finding the complex zeros of a function. We're going to do exactly what we did 2 sections ago. We're going to do the whole P over Q stuff. It will depress down to a polynomial that you can then factor in other ways. Basically what we do is we depress it down, into typically what's a quadratic. Now we're going to do that with this one in a couple minutes, but before we do that, let's take a look at a different way of approaching this. They will give you a function and they'll tell you that some complex number is a 0. Well, if negative 5i is a 0, that's supposed to say plus 5i is a 0 as well. So, well, it's a typo. But since negative 5i is a 0, we need to know that the conjugate is also a 0. So I'm going to go ahead and make my factors and multiply these factors together, and I end up with x squared plus 25, because one of them is plus 5i, one of them is minus 5i. There's no real portion there, so there's no x term. With no real portion in the complex number, there's no x term. So I get x squared plus 25. Well, because this is made from my factors, x squared plus 25 is a factor of the polynomial. Well, I'm going to go ahead and divide. Okay, so this is my new way of showing the long division. I used a parenthesis and a bar. I hope you like it. I guess I don't care if you don't. And I'm going to do this long division. I can't use synthetic division because I'm dividing by x squared plus 25. So when I actually do this division, I get x plus 3. Bam! I just found another factor, the third factor for my function. So I know that my zeros are negative 5, that was given. Excuse me, negative 5i, that was given. 5i, that's the one I knew I needed to add. And negative 3, opposite what's with the x there. Okay, so what if they don't tell us a complex 0, just like the f of x equals x to the fourth minus 1? Well, it starts out just like it would have 2 sections ago. Do the whole p over q stuff. Now my p over q's, I've only got plus 1 or minus 1. And I know that 1's going to work because if I plug in 1, I get 0. So I depress the equation just like I would have 2 sections ago. And yes, 1 works. My synthetic division shows that. And I get a new polynomial, x cubed plus x squared plus x plus 1. Well, I want to depress this. Well, let's see. Is 1 going to work again? No. But negative 1 will work. So I depress the equation again. I see that negative 1 works, so that means that negative 1 is a 0 of this function. And what I'm up to at this point is a quadratic. When I have 3 numbers in front of my remainder, that's a quadratic. Specifically, this quadratic is x squared plus 1. Now I change gears, just like I did 2 sections ago, except this is going to give me some complex zeros, and I'm not going to ignore those. So I take that quadratic, I set it equal to 0. Maybe I want to use the quadratic formula. Maybe I want to try to factor it out. I'm going to go ahead and move the 1 over, and I get a negative 1. Take the square root, I got plus or minus I. So I have 4 zeros, 1 and negative 1. Those are my 2 real ones. And then I and negative I. Now, that's basically it for this lesson, and all that's left is a whole bunch of practice for you, homework. I need you to remember, they have made these to work. They've made these so that you can find the real zeros, get those teased out, depress it down, depress it down, depress it down, and then find your complex zeros. You have to have that little bit of faith that yes, they made these so that there's a real 0 that I can find. Okay, time to get to work. So that means I'll see you in class, and I'll see you online.